We are going to talk about repeating decimals, also known as recurring decimals. Recurring decimals. What are they? Let's first see what are they and then analyze them. So if you divide, for example, 1 by 3, you can right now put it into your calculator. 1 divided by 3. What do you get? You will see that it will display for you 0.33333. And as large as as powerful as your calculator is, you're going to see 3. So these 3's after the decimal points are repeating. So it just continues forever. That's why we call this repeating decimal. This is a repeating decimal or a recurring decimal. Okay. Now, just for not writing so many 3's here, people show them like this: 0.3 and the bar on the top. So this is the same as writing infinite number of 3's. The bar on the top of the 3 shows that this 3 is gonna get repeated over and over. So as I said, you get this as the result of dividing 1 by 3, right? So this is basically a fraction 1 over 3. Nice. Now what if I give you a recurring decimal like 0.6666 and forever 6, or I can just show it simply like this: 0.6 repeating, right? A recurring decimal, 0.6 repeating. And if I ask you, this is equivalent to what fraction, what over what, right? What divided by what will produce 0.6 repeating? How would you answer that? That's what we're going to learn in this episode. Let's see. 0.6 repeating. Okay. We have to do a trick in here. First of all, let's consider this 0.6 repeating. Let's give it a name. I'm going to give it a name. Let's call it X. Okay? So 0.6 repeating is X from now on. If I multiply X by 10, what is 10X? 10 times X, what is it? So 10 times X is 10 times 0.6 repeating. And what happens when you multiply 0.6 repeating by 10? Well, the decimal point here, because you're multiplying by 10, the decimal point shifts one position to the right. So the result is 6.6 repeating. Okay? Now, why did I do that? You will see why did I do that in a minute. So now 10x equals 6.6 repeating. All right, that's good. Now, is there any way I can get rid of this repeating portion? 6 repeating, right? Look at, in the original number we had 0.6 repeating. What if I subtract 10x from, if I subtract x from 10x, so I write 10x minus x, what do I get? Basically, I have to subtract 6.6 repeating that minus 0.6 repeating. What would be the result? This is exactly, I'm subtracting all these repeating 6 from 10x. So these parts get cancelled because we're subtracting them. So the result is simply 6. Basically, 10x minus x equals 6. 10x minus x, 10x minus 1x, that's 9x. So 9x equals 6. Now, if you divide both sides by 9, you can isolate for x. I divide both sides by 9, I get x alone on one side. X equals 6 over 9. Okay? So we basically realize that 0.6 repeating is equivalent to 6 over 9. And you can double check that in your calculators and see if that's true. Also, of course, you can simplify this fraction and write it, instead of 6 over 9, you can simplify it by a factor of 3, because you know 6 is really 3 times 2, and 9 is 3 times 3. So I can simplify, cancel out the factor of 3 from top and bottom. So this fraction simplifies into 2 over 3. So 0.6 repeating equals 2 over 3. 2 divided by 3. As I say, you can double check that by your calculators. Let's see another example. Look at this recurring decimal. 1.23 recurring. So now instead of 1 digit recurring here or repeating, we have 2 digits. So this basically means 1.232323 all the way for forever. That's why we put the bar on 2 and 3, both of them, because they are the both of them are the repeating decimals. How do we convert this now to a fraction? This equals to what over what? It's a somewhat the same process as we did before, but here, because we have 2 repeating digits, instead of I multiply that, so first of all we call it x, but instead of multiplying by just 10, I multiply it by 100, so that the decimal point shifts to the 2 positions to the right, by multiplying x by 100. So 100x equals 123.23 recurring. We multiplied by 100 because we had 2 recurring digits. When we had 1 recurring digit, we multiplied by 10. We have 2 recurring digits, now we multiply it by 100. Now the benefit of that is we can right now simply subtract 100x and x. So basically having this subtraction 123.23 recurring minus x is 1.23 recurring. So you see now the 2, 3 recurring, they get canceled from each other. But we also have 1.23 repeating. So if I write that answer, we get 122, because of this 1 also gets subtracted from 3. So we get 122. Nice. 100x minus x, what is the result? Is 99x. 99x equals 122. Now let's find x again. Let's isolate for x. So I divide both sides by 99. X equals 122 over 99. That's the equivalent fraction to this recurring digit. Let's see another example. 3.145 repeating. So the difference here is that we have 1 non-repeating digit and 2 repeating digits. So what difference does it make now? First of all, let's expand this number and see how does it exactly look like. It's 3.1454545 all the way to infinity. Now the question is, how do we convert this into a fraction? This number equals what over what? As usual, let's give it a name. We call it x. Now, I'm going to one time multiply x by 10. So 10x. Why do I do that? I want to put all the non-recurring digits to the left of the decimal point. So we have one non-recurring digit. I multiply it by 10 so that I move the decimal point one position to the right. Basically, we will have 31.45 repeating. That's 10x. Okay. Now, if I subtract x from 10x, I'm not going to get much. I'm not going to completely eliminate the recurring part because we have this 1, x equals 3.145 repeating. So this 1 is now in the middle of the way. It does not, if I subtract the 10x from x, x from 10x, the 45 repeating, they don't get eliminated completely because this non-repeating digit. So we have to think about something else. How about I multiply 10x by 100, so overall, so basically 100 times 10x. Why do I do that? So that I shift the decimal point 2 more digits to the right, so I include the 45 here. So we will have 3145.45 repeating. Now the benefit of doing that is that if I subtract these two, now I can eliminate the recurring decimals completely. So basically I have this subtraction. 100 times 10, that's 1000. So 1000x minus 10x equals, alright, so we have 3145.45 repeating minus 31.4145 repeating. Now you can see exactly the 45 repeating gets eliminated. So the result is 1000 minus 10x, 1000x minus 10x, that's 990x equals 3145.45 repeating minus 31.45 repeating. First of all, the decimal part completely eliminates. And now you have to subtract the remaining 3145 minus 31. The result is 3114. That's the result. Now isolate x, divide both sides by 990. So x equals 3114 over 990. That's the fraction that represents this recurring number. So let's summarize, recap. Sometimes we have recurring numbers looking like this. For example, 1.33333 all the way to infinity. So we said to just shorten the writing, to summarize, we just show it with this notation. 1.3, we put a bar over the recurring number. So you can see here we have only one digit repeating here. In these cases, if you want to convert them to a fraction, we call it x and then multiply it by 10. Just multiplying by 10 because there is one repeating decimal. This is, let's call it type 1. Type 2 was when we have more than one repeating. So for example, 0.15 repeating or 0.123 repeating. In these cases, we multiply, instead of by 10, we multiply it by the how many repeating digits we have. So in this case, we multiply it by 100. In this case, we multiply it by 1000 and so on. And then we subtract the two, x from 1000x and then we can isolate for x and convert it into a fraction. In type 3, we have also some non-repeating digits. So for example, 2.34 and then 7.1 repeating, right? So in this case, one time we take care of non-repeating digits, multiplying, for example, 2 non-repeating digits we have. So first we multiply by 100. Then we also take care of the repeating digits. So another time we multiply it by 100. And then we subtract the 2 and we can eliminate the repeating digits. So overall, we have these 3 types. So let me know if you have any questions, any comments, any suggestions for more videos. Thank you for your attention.